Okay, these are the first two examples from the practice for the final exam. I'll run through them quick. When you do these on your final, just make sure really fast that 0 is 0. They will be, or there's no point in doing L'Hopital's rule. So these couldn't be done with the techniques you learned in the beginning anyway, so you have to use L'Hopital. This is chain rule. The derivative of e4x is 4. e4x, the derivative of -1 is 0, it's gone. Derivative of 2x is 2. Derivative of sine 3x is cosine 3x times 3. That negative has to stay there. Now I'm going to plug 0 in. Remember, write lim until you plug in 0. A lot of you don't write the lim. I have to write it for you. It's going to cost you 1 point. Plug 0 in for x, you get e to the 0. There's no x there. Plug 0 in here. E to the 0 is 1. So you get 4 times 1 on top. 2 stays. Minus, now cosine of 0 is also 1. So on the top you get 4. On the bottom you get 2 minus 3, which is -1. So the overall answer is -4. Now this one, same thing. You get 0, 0. Do L'Hopital rule. Derivative of the top is 3x squared minus 3. That was interesting. The derivative of 2 is 0. Now the derivative of ln u, remember, it's du over u. So take the derivative and put it on the top. The derivative of 2x minus 1 is 2. And put him on the bottom. Now you got to plug in 1 again. So you get 1 goes to the top. And then 1 goes down here. So you get 1 squared, which is 1, times 3. This is interesting. 3 minus 3. On top, hello. On the bottom, you get 2 over 1. 2 times 1 is 2. Take away 1 is 1. So on top, you get 0. Don't be fooled by this. 0 divided by 2 is 0. I give you my guarantee this will not work out this way on the final. I don't like the way this answer works out. All right, I'm going to do 2B from the sheet. The first question is the quotient rule. Bottom derivative, top derivative, bottom. People don't get this wrong, so I'll focus on the one I saw people make mistakes on. First, I want to point out again, the way I gave you the product rule was first, derivative second. Derivative second is 12x squared. So first derivative second, let's write it more legibly, plus second derivative first. Now remember, when you do ln u, it's du on top, which is, so put the derivative on top and put him underneath. This is the faster way to do this, okay? Instead of doing 1 over u du, whatever other weirdness you have to do. Just put him on the bottom and put his derivative on the top, okay? So first derivative second plus second derivative of the first. Now I got to simplify that. Put this in the front, just so you're not tempted to hook it up with this x third there. And some of you did on this exam. Now, this, right, you have x squared on top, x third on the bottom. That's 3 over x. So I'm just going to put that there to make my simplifying easier. So you have 4 times 3 on top, x squared dividing away 1x, x cubed dividing away 1x leaves you with x squared. Don't get cute with this. I know the programs will factor out the 12x squared into the front. Leave it the hell alone. This is your answer. Okay, here's the third question. I'm going to try to do this kind of quick. This was originally radical x. I already rewrote that. I probably should have rewrote the whole thing to save time. So I'm going to. Radical x, you put x to the 1/2. This one you're going to move up is x minus 2. This is x to the 1/4. I'm going to move that up because they're on the bottom. I have to move them up and switch the powers. And then radical 4, hello, this is a 2. So I'm going to switch them, and then like magic, you'll see it change. Poof, it's changed. Now I got to take the third derivative one at a time. Multiply by the power, subtract 1. Multiply by half. 4 times a half is 2. Subtract 1. A half minus 1 is -1/2. The derivative of sine is cosine, but I have negative sine, so it stays. Multiply by the power, subtract 1. Multiply by the power. Now, I'm multiplying 12 by negative 1/4. So just divide the 12 by the 4. That's my sloppy half-ass scratch work. So it's going to be minus 3x. Now you have to subtract 1 from that, which is 4 over 4. So you get negative 5 over 4. Here you're going to get 3x squared plus 16x, and the derivative of 2, boop, bye-bye, constant. So now the second derivative, take half of 2, well, excuse me, negative half of 2, that's going to be a negative 1. Subtract 1 from the power again. Now this time be very careful. The derivative of cosine is negative sign, but you already have a minus there. So this is going to become positive 3 sine x, right? The sign switch happens when you take the derivative of cosine. Multiply by the power here, you get positive 6x, subtract 1, negative 4. Now it's going to start getting harder. Negative times a negative is positive. 3 times 5 over 4 is 15 over 4. Again, subtract 1 from the power. This is going to start to get pretty big. You get negative 9 over 4. This is not going to happen to you on your test. I'll make the number smaller than this. You got plus 6x plus 16. And finally, the third derivative. This is the one that you're supposed to do. Multiply negative, negative is positive. So you get 3 halves x to the negative 5 over 2. This is more of how I'll keep the numbers on the final. This is way too friggin' big. Derivative of sine is cosine. So just keep that 3 there. Multiply by the power. This is also reasonable for me to expect from you. 6 times 4. And then subtract 1 from the power. This is not reasonable to expect to make you do 15 times 9. I mean, I know that 15 times 10 is 150. And then I'll take away another 15. So I know it's 135. But it's still ridiculously big. So this is not going to happen. So you get negative 135 on top, right? 15 times 9. And then 4 times 4 on the bottom. And once again, subtract 4 over 4. So you get negative 13 over 4. This is garbage. Ignore this. I swear this will not happen on the final. Derivative of 6x is 6. Derivative of 16 is a constant. It's gone. So this is the final answer. The only part is this one. This is not going to happen. These numbers are way too big. I will make sure that the numbers are not this big on your final exam. So you just ignore that stupidity. All right, here's question 4, the popular one that everybody was asking me to do. Sand pours and forms a cone, blah, blah, blah. The height is 6 times the radius. The height of the pile increases at a rate of, so dH dt. They're giving you dH dt. They're also giving you h equals 4 at the end. They want to know at what rate is the sand pouring from the chute. So as the sand pours, it makes a cone. So they're really asking you at the rate of change of the volume. So remember, the volume is 1/3 pi r squared h. And yes, you'll be given that formula, just like you were on the third exam. Now, again, the mistake people make, they don't read the question carefully. I am giving you dH dt. If you just take, oh, h is 6r, put a 6r here, you have already failed. I mean, you, okay, fine, put 6r there. Now what? If you take the derivative, you're going to get dr dt. I don't have dr dt. I'm not asking you for dr dt. You can't replace h. You have to replace r. So you have to go back and solve this problem for r and put the r there. So you have to read carefully what you're given. If you were given dr dt, you would replace h, but I was given dh dt. I need that, so I have to get rid of r. So where r is, you put h over 6. Square that, right? R squared. Now multiply it out. Again, this is not that bad. You get 1/3 pi. H times h is h squared on the top. 6 times 6 is 36 on the bottom. Times h. Now, I'm not going to multiply it. All I'm going to, actually, I'm going to just leave it like that. I'm going to put 1/3 pi h to the third, right? H squared h1. I don't want to do, I know what it is, but I don't want to multiply it. Now, another mistake people make. They're already writing dv dt here. Please don't write dv dt and dh dt until you've taken your derivative. If you do this, then you show me that you don't understand what you are doing. So now that I have my formula simplified, even though I didn't do 36 times 3, dv dt is the derivative of v. Multiply, right? Keep the 1/3 pi there. Derivative of h third is 3 h squared dh dt, and what's still there? 36 on the bottom. I'm going to knock out this 3 and this 3. I'm going to replace h with 4. The problem is over. It's done. And dh dt is 3 over 2. I have everything I need. I knocked out this 3 and this 3. So I'm left with pi 4 squared, which is what h is. H is 4. I still have that 36 in the bottom that I decided to leave alone. dh dt is 3 over 2. It's a very strange number. It is what it is, just an exercise in fractions here. 4 squared is 16. 36 on the bottom. You get 3 here, you get 2 here. I mean, you might as well, I mean, yeah, I can reduce, these are both divisible by 4. But why not knock 3 into 16 first and put 3 into 36 and then put 2 into 16? So I'm going to get super cute. I'm going to do 16 over 2. And I'm going to do 3 over 36. You don't have to do this. You can simplify this any way you want, just please. Don't do 16 times 3 is 48 and 36 times 2 is 72. That's moronic. I didn't like the way I wrote it. So 2 goes into 16 8 times. I didn't forget my pi. It's still there. And then 36 divided by 3 is 12. So right, I have 8 on top, 12 on the bottom. Now, divide them both. I mean, I did this sloppy as hell. This is bullshit. This is arithmetic. So if you can't do this on your own, I mean, what the hell? So 8 divided by 4 is 2. Pi goes next to it. And then 12 divided by 4 is 3. So this whole big stupid mess, in whatever order you feel like simplifying this, you get 2 pi over 3, all right? And this is how you leave the answer. I wanted dv dt, so I'm done. All right, this is a modified version of 5a. I eliminated the first term because it's moronically easy. I'm only doing the 2 terms that people could get wrong. I have to rewrite this one and this one. This one is going to be cosine x to the 1/6 power. How do I know that? Because it's a radical with a 6 there. This is the 6th root. My 1 strung a little too close to my division. Now, I have to move this. Here is the mistake that people make. When they rewrite this, they just write 2x to the -8. This is completely wrong. This is 1/2. You can't tell me that 1 over 2 and 2 are the same number. 1 divided by 2 is not equal to 2. So this 2 has to stay down there. This number will be there. So you have to make sure you only move up to x. So you have x to the -8. Now I take the derivative, multiply by the power, subtract 1. This is not a chain rule. This is just a regular question. So then do -8 divided by 2. You get -4 x to the -9. Leave it like this. Don't move this back down as x 9th the way the solvers do. Now here, this is chain rule. This is your u. You have u to the 1/6. The derivative is 1/6 u to the -5 over 6, right? Subtract 1, 6 over 6, times du. So I know I'm going to need the derivative of this eventually. Multiply by 1/6. Leave this alone. You don't take the derivative here, -5/6, times the derivative of the inside. The derivative of cosine is negative sine. Now, the only thing you can do when you write your answer is just take this negative and put it in the front. I mean, if you want to, you could put that in the front, but you can leave it the way it is. So it's -1/6 cosine x, -5x times sine x. Like I said, you could put that in the front if you wanted to. All right, so this is 5b. So again, ln u. Put the u, there's your u, there's your u. Put the u on the bottom. This is just basic chain rule. Did this already. Put secant 2x down at the bottom. Now I got to put his derivative on top. The derivative of secant is secant tangent. So, but I have secant 2x. So it's secant 2x tan 2x. Make sure you put the 2x's there. But I'm not done. I need the derivative of 2x, right? It's secant u. So you have to do du. So you just put the 2 in the front. Now, look, they match. Yay! Cross them out. So you just get 2 tan 2x for the first part. Now for this part, the derivative of tangent of u is secant squared u du. These are all in our chain rule list. So there's no reason to write them again. I'm just doing them for you. So the derivative of tangent of some stuff is secant squared of the stuff times his derivative. Done. It's not that difficult. You know, write the 2x in the front, make it look pretty. So 2x goes in front, so you get secant squared of x squared. Remember, this is not a product. Make sure you put secant squared. Don't put secant squared x and then x squared minus 1. Now again, you have a 2 and a 2. Don't do anything cute with this. Don't factor this out. You can't add them. You can't combine them. Don't do no weird shit. This is your final answer, so you stop. All right, question 6. I apologize for my lighting here. I mean, I have all my lights on. It's not helping much. So this is the tangent line done by implicit differentiation, everybody's favorite. You have to take the derivative of both sides with respect to x. And again, I'm skipping writing. I'm doing this very half-assed just to show you guys answers. So you get 6x squared here. X, right? dx, x, it matches. But when you take the derivative with respect to x of y, the derivative of negative 5y is negative 5. But it's negative 5 dy dx. Derivative of 4 is 0. It's a constant. Derivative of 4x is 4. The derivative of y squared, well, it's negative y squared, is negative 2y times dy dx. Now you have a decision to make. I can move this to this side and then move this to that side. I mean, it does, or you can move this to that side. It doesn't matter. I'm going to collect all the y's to this side. So I'm going to add 2y over to this side and cross that out. And then I'm going to subtract the 6x squared from this side and move it over to there. So I'm going to end up with 2y minus 5. I'm cheating here. dy dx. On the other side, I'm going to have 4 minus 6x squared. Right? This comes over. You know, it didn't start this way. It was 2y dy dx minus 5 dy dx. And I factored out the dy dx. And I'm going to put that on the other. I'm going to divide it away. I mean, I want to do the problem with some relative speed here. So I'm skipping that step. You do not have permission to skip that step. You must show me that step. I want to see the step where you had 2y dy dx and 5 dy dx, and then you factored it out. Don't be cute like me and skip that step. Now, this is the derivative. The problem is I need the slope of the tangent line. So what I have to do now is plug in a -1 for x and a 3 for y. So wherever you see x, you're going to put -1. I mean, I have no idea how this is going to come out. And wherever you see y, you're going to put 3. Oh, I made it come out so nice. So on top, you're going to get 4. Look, -1 squared is 1. -6 times +1 is -6. So on the bottom, you get 6 minus 5. This is your m, right? On the top, you get -2. On the bottom, you get a 1. I mean, this could not have been more of a gift. Now, let's see, do I have enough room to fit? I guess. Y equals mx plus b. M is -2. X is -1. And y is 3. Negative times negative is positive. That's +2. So it looks like b is going to be 1. So my tangent line is y equals -2x plus 1. So just recapping super fast. Take the derivative of all the terms with respect to x. X's you do like normal. The y's you do like normal, but you add on the dy dx. Solve for dy dx. Plug in the numbers I gave you. Get the m. And then use the mx plus b to figure out the b. Easiest thing to do. Easiest way to do it. Okay, the hard problem with the box. Everybody's favorite. So I drew the box. It says the volume of the box, which is the length times the width times the height. I know that the bottom is a square, so the two sides are x, and the height is h. So the volume is going to be x squared h. And I tell you that the volume must be, I believe, 256. And then it says, find the dimensions that will minimize the surface area. So remember, the area of all the surfaces. You have a bottom and 4 sides. So what is the surface area? This is what you are trying to minimize. This is your min equation, the M equation. It is the area of the bottom, which is x squared, plus the area of each of the four sides. So the area of one of the sides would be x times h, and there's four of those sides. So this is what you're trying to take the derivative of because you need to minimize it. So the only thing screwing this up is the h. So you need to solve the top one for h and plug it into the bottom one. So divide by x squared and then replace it. So in your M equation, you're going to put 256 over x squared. Now, I'm going to be honest with you. You don't even need to multiply this by 2. You're going to end up canceling this out when you take the derivative and set it equal to 0. But, you can multiply it out. If you don't have a calculator, I'll show you the moronic thing to do. 250 times 4, 250 and 250 is 500, right? Double it and then double it again. So this is 1,000. 6 times 4 is 24. Hello. So it's 1024. I won't give you numbers this big. I promise. You won't have a calculator. So if you really felt like multiplying it out, it's 1024. Now, x1 over x2, right? The larger power is on the bottom. So if you did 1 minus 2, you get -1 there. It doesn't matter what you put. You're going to take the derivative of it in a minute. So this is your min equation. Take the derivative. The derivative of x squared is 2x. Multiply by the power. Subtract 1. And set it equal to 0. You're trying to find the min or max, and here it's a min. So you must set the derivative equal to 0. Now, bring this to the other side, and I'm going to move that down simultaneously, right? Equal. This goes on the bottom. It's 1024. X to the minus 2 comes downstairs as x squared, right? This is the move. I added this to this side. That's why the minus isn't there anymore, right? I did plus 1024, da-da-da-da. So that's why it's not negative. Now, cross multiply, crisscross. This goes over here. This is why it didn't matter if I multiplied that out. Divide by 2, right? I'm going to cut it in half. So you get 512. Do I expect you to know the cube root of 512? No, I don't. That is the reason why I won't make the numbers these big. I have to do this on the calculator. All right, so I paused a second there. The cube root, this is apparently 8 times 8 times 8. I mean, hell, I don't even know what the cube root of this was. You will have a number here you can do. This will be like an 8 or a 27 or a 64. I won't go bigger than 64. So, the cube root of 64 is 4 times 4 times 4, right? So it's 4. So if it was 8, obviously it would be a 2. So now that I know that this is 8, I'll tell you a big secret, though. This problem with the open top, the height is always, 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 without exception, half of what x was. So I already know it's going to be 4 without even doing it. So you'll have 256 divided by 64. I don't need to check this on my calculator. I know how the problems are designed. I know that the height will always be half of whatever x is. If x were 10, this would be 5. If x were 16, this would be 8. Whatever this is always half, always. So the dimensions that would minimize the surface area that you use would be length 8, width 8, height 4, right? It asks for the dimensions. And if you multiply that out, you do get 256. All right, this is the last one that I'm going to work just because some people got it wrong on the last exam. And 8A is finding the antiderivative. It's very basic. I mean, this one I don't really, they're in the video lessons I did anyway. First thing you have to do is find the antiderivative. But before you do that, you got to clean this one up. This is 4 over x to the 1/2. And then you got to move that upstairs. So let's just do that. It's 4x to the minus 1/2 dx. Now I'm ready to find the antiderivative. Add 1 to this power and divide. Add 1, you get x squared, divide. 2 cancels out to 2, you get x squared. Here I'm going to add 1 to this power, which makes it x to the 1/2. Now, remember what I told you to do. Take that power. There's already a -4 there. Take this power, flip it over, and put it in the front. So you're going to get -8. So you're going to have -8 x to the 1/2. And don't leave it as x to the 1/2. X to the 1/2 is radical x. And now here's where a lot of you screwed up. You put a plus c or you put a dx. What dx? This is a derivative. This is the original function you started with. There's no dx here. This is not a derivative. This is the original guy. This is your antiderivative. But you want to put the line there to indicate that you are about to plug in the number 4 and the number 1. Now, I'm not going to have a 4 in the final because I know that people will see that 1/2 power and just try to cut this number in half. That's why you'll see a 9 here. So you can't cut 9 in half. People don't know. They do it wrong. So 4 squared minus 8 radical 4 take away 1 squared minus 8 radical 1. Square root of 4 is 2. That's 16. So that's 2 times 8 is 16. Yay, it goes away. 1 take away 8 times 1 is 8. Hello. So that gives you negative 7. So this is 0. Minus 1 take away 8 is negative 7. Negative times a negative is positive. So there you go. That is the last question. All right. Antiderivative, plug the numbers in, evaluate it. Easy peasy.